Hello and welcome to the latest webinar in the 42Crunch series, exploring all topics related to securing and defending your APIs. Today's webinar explores the hot topic of how to combine a shift left and shield right approach to protecting and monitoring your APIs. In this session, our speakers will discuss the principles of applying a DevSecOps model to API security and incorporating a SIEM for monitoring and alerting. We'll also give you a live demo showcasing how you might leverage your existing investment with Microsoft's Azure Sentinel and the 42Crunch API security platform to achieve full end-to-end API security. So before we start, I'd just like to introduce our speakers. First up, we have Colin Demoni from 42Crunch. Colin heads up our developer advocacy initiatives. He's an API security researcher and also edits the industry-leading weekly API security newsletter, apisecurity.io, which is powered by 42Crunch. And we're also very pleased to welcome Sagi Haim from CyberProof. Sagi is a cloud security solutions architect, team leader there, and he's based in the Valley. He's also a Microsoft MVP, most valuable professional, recognized for his community leadership. And he also writes the blog, Sagi Haim Automate Everything. So worth checking out if you've got a moment. Where he writes about all things Azure Sentinel related. Okay, so I'll hand over to you, Colin. Take it away, please.
Yeah, thanks very much. Thank you, everybody, for joining a 42Crunch webinar again, and very pleased to have Sagi Haim from CyberProof. I used to work with Sagi a year or so back. Great to have you and talking all magic about Sentinel, so welcome.
Thank you for joining.
Yeah. So the agenda today, quickly, we're going to go through, the threat to APIs and 42Crunch's approach to API security, shift left, shield right. And then we're going to look at our firewall product, which is kind of core to the shield right proposition. Sagi's going to talk a little bit about CyberProof, Sentinel, MITRE ATT&CK frameworks, various topics on threat detection and response. And then it's going to be demo. I think we're going to spend most of the time in the demo today having a look at what we can do to connect your APIs to Azure Sentinel. And then we wrap up with the benefits of the solution and hopefully time for Q&A. So keep the questions coming in. What we find normally works well is if you ask questions as we go. So without further ado, let's get started. So, APIs are now the #1 attack vector. If you subscribe to the apisecurity.io newsletter, you see that there's almost a vulnerability per week or more that are happening. APIs are, the top choice for attackers. And there's a couple of reasons for this. So, we have now heading toward 200 million public APIs. Nearly all organizations are reliant on APIs. And 91% of organizations experienced a security incident relating to the APIs, right? There's a bit of a problem here with APIs because, they're almost a victim of their own success because the APIs are easily discoverable and because they're documented. And attackers have really interesting tools that they can use to attack APIs. We look at one of them later. They make themselves a very easy target for attack, right? So the ubiquity and the fact that they're exposed is kind of creating this impact point that we have now. So what are the threats to your APIs? Firstly, let's think of who is attacking these APIs. So in advanced level of sophistication, we've got, what we call script kiddies. These are people that are using public resources. They're going on, they're playing with Kali Linux, and they're just trying to scrape and attack an API. Probably unlikely to cause much damage, but they can be fairly annoying. And obviously, if they're creating security alerts and incidents, you've got to go in and have a look in and kind of investigate what's happening. Then we get to the kind of gray area of the crossover between, scripts and then scrapers and bots. Now, these are things that may or may not be malicious, right? They might be things like, so scrapers, they basically try and pull lots of data out of your API, right? It's not necessarily hacking your API, but they're using your API in a way that you didn't expect it to be used. A good example here is airline pricing sites. A lot of the airlines, they exposed their pricing information via public APIs. And what did the competitors do? They went and scraped that, and they then made sure that they could price just under what market rate was. So it's kind of abuse or misuse of APIs. And then obviously bots being able to launch scalable distributed attacks. And then the people we're really worried about, these are the hackers. These are the, the people who are, if you're lucky, they're running bug bounty schemes, and they white hat. If you're unlucky, they're trying to, destroy things, install ransomware, and whatever these other various means, or they're trying to just take your website down. The dangers in your API, we've got these proliferation of APIs, and unfortunately we have, a number of APIs, shadow APIs. These are things we don't know that exist. Zombie APIs, these are APIs that are deprecated and no longer maintained. We've got APIs that are misconfigured, that have just been set up incorrectly. And then we've got so-called Frankenstein APIs, which are developed in a non-standard manner, right? So then normally what that means is they're not protected in a standard manner. We look at a number of scenarios for protecting, for attacking APIs. The first one that we're going to look at the type of attacks. So we've spoken about bots. One of the other attack techniques is just to enumerate and discover endpoints. We look at Kite Runner a little bit later in the demo. We've got denial of service. I might just thrash away at an API and try and take it out of service. We've got credential stuffing attacks where we use dictionary attacks on APIs. We can extend that and try and do account takeovers. If we've got a password reset function, we can abuse and hack that. And then, as said, you can also, paginate and scrape data out of the API. So lots of ways that your API can be abused. So first poll question that we've got coming up, if you could promote that, please. We're going to ask you what you consider the number one, just pick one of those, the number one threat to your APIs. So it's a bit of a mixed bag on the answers there. We'll just give people a moment to respond, and also just to get those questions coming in. We've got the answers in, so that's probably what I would have expected. Lack of visibility, nearly half the respondents saying that the lack of visibility is probably the number one issue. And then secondly, not surprising either, that commercial cyber criminals abusing APIs. So great. So I'm going to talk about 42Crunch very briefly for people that aren't familiar. I know we've got new people on this session. How do we approach API security? So as I said, it's a two-pronged approach. So shift left, the industry, DevSecOps is now a thing. It's been around, better part of a decade. I've been doing DevSecOps. I think the industry understands the benefits of shifting left and doing security as early as possible, right? There's a number of benefits: reduced cost of deployment, rework. You reduce risk as early as possible, and most importantly, you make the developers aware of the security concerns, right? So they part of the security solution rather than waiting until something goes wrong. And you secure by design rather than by testing, right? So we know that a shift left, is a sound approach. How does this apply to API security? Well, we're a firm advocate of shift left for API security, but we acknowledge that it comes with challenges, right? So there's a number of scenarios, particularly around APIs, where you have APIs that your process isn't really going to be suited to shift left initially, right? And this is where the importance of shield right comes in. So you don't have an existing DevOps process. You've got legacy systems. You've got APIs that are already deployed. You've got these shadow IT APIs that you don't know about. You've got third-party partner APIs that you don't control. And maybe you've just hacked your API code you haven't designed first, and you don't have the OS definitions. So shift left can be challenging. So what we do is we provide we call the 42Crunch Protection Micro-Firewall. It's a small memory footprint, highly performant API that's designed. It operates as a reverse proxy. It sits in front of your API endpoint. It's able to connect to the 42Crunch platform, and it's able to ingest your OAS definitions and give your API backend the protection against that contract. Right. So we have a look how this works in a sec. So not only does it do the protection, but it also is able to generate logs and event logs to platforms, to the 42Crunch platform, or what we show in this demo, we show it talking to the Azure Sentinel. Right, so that's setting the scene. So shift left, shield right gives you that full coverage around your DevSecOps lifecycle. So question two, this perennial problem that people have is how many people are doing what we call design first? So who is starting with, looking at your API portfolio and your inventory, who's working on a design first basis? Good to see that there are people that are using APIs first. I guess the problem is, a lot of people are migrating to a design first approach. There are lots of ways that, we'll have blog articles on this and how to get definitions out of existing APIs. There's lots of techniques that you can use to get you down this design first, or at least spec-driven approach. So I'm going to hand over to Sagi now, but before I do, I'm just going to, in the interest of transparency, because this comes up later in the demo, I'm just going to show, I've got a Slack session here, and I'm just going to prove that there's nothing in the Slack session. Now, if I could spell. Right, so I've posted a message in there, that's a marker. And we're just going to flip over to the Sentinel platform, and we'll have a look that at the moment we've got an empty, there's no incidents active, right? Because this is where we get onto the demo in a second. So without further ado, I'm going to drop over to Sagi now to take us through CyberProof.
Thank you very much. So, okay, everyone. First, Colin, thank you for having me here. For those who don't know CyberProof is an MSSP company. We are based in Israel. We have 600 more employees around the globe to provide security services. We named leader by Forrester in both 2018 and 2020 for mid-sized managed security services. We also named as a leader in North America in 2021, Rising Star. And a lot of us are former 8200 unit in the Israeli Defense Force and counter-espionage. This provide a lot of experience that came from serving the Israeli army and doing a lot of stuff for nation state. We are certified in CERT and ISO 2701 in Trivandrum, Barcelona, Singapore, and of course in Israel. Now, CyberProof provide a lot of services. Our main services, of course, is our managed services. On top of our managed services, we have a platform that we developed called CyberProof Defense Center. This is a cloud-native orchestration, collaboration, automation platform, which enable us to deliver our services together with our customer. We provide services to proactive and specialized services to reduce attack exposure around a lot of areas. And we also provide the consulting services in order to help you build your strategy, work on your environment, and of course, reduce your risks around various areas like DevOps, cloud, development, DevSecOps, and many more. Next, please. Now, what different CyberProof from other MSSPs are the areas that we focus our innovation on. So we build a bot that is integrated inside our platform. His name is Simo, and we will talk about it a little bit in the next slide. This allows us and your team to automate alert triage and enrich the information inside the platform, and of course response to incident. We have one of the things that we are doing with the CDC is that we enable visibility. So a lot of MSSP is like a black box where you get a service and you get updated by emails. In our case, in our platform, does the opposite. We collaborate a lot, we show a lot of visibility, and we let you be part of us. We are working together as partner and not some kind of a vendor provider. And of course, we have the use case factory that allow us to really go and look on the risk that related to your company and to your industry, in order to always continue deliver use cases around the risk that related to you. Next, please. Now, a little bit about the CyberProof Defense Center, as I said. So inside the platform, we heavily invest in automation. So it means that we really want to give our SOC team and your SOC team the tools in order to automate, because we know that one of the biggest issues today or challenges today that we have in the security area is the manpower and the amount of events that we have. So smart automation allow us to reduce the amount of events and the amount of time that we spend on each incident in order to provide much better efficiency, and of course reduce the alert fatigue inside any SOC that we see in the world. We have, as I said, a great collaboration platform. This means that we are working together. We have a chat ops that we can interact together and see what's going on. Like anytime we can speak about the things. You can ask questions. We can write points. We have the collaboration that you can see exactly what the teams are doing, how they are doing it, and why they are doing it. Together with the CMO, we have a lot of enrichments and a lot of capabilities that we can give you in order to gain visibility faster. We have playbooks, we have incident prioritization. So we can have a lot of incidents inside the platform, but we want to understand which one are the most critical and the most important one to focus on. So this is where our platform know how to classify the incident and provide you the priority. And of course that we have very good KPI-based reporting. So our platform doesn't address only the analyst, it also provides a lot of information for the SOC manager and of course the enterprise, the executive in your company, in order to provide you a lot of visibility on what's going on and how we are improving your security posture. Next, please. So those are the type of events, of reports that we provide in order to give you those insights. One of the most important things is that we want to show you how we improve your security posture. And it's not only about creating more detection rules, it's about the processes and about the operation and how fast we are closing incidents, so time to response, and how we are reducing over time the amount of incidents that are being escalated from L1 to L2, and how the teams are working much more efficient as we going forward. And this is, as you can see on the screen, is just one example of many, many other reports that we have inside the platform. Next, please. So CMO is, as I said, is our virtual analyst. We think that this is the future, and this is where we invest a lot right now. So inside the platform, you will meet CMO. He will do a lot of things automatically for you, like smart enrichment. So when we create an incident will raise in the platform and we have alerts, so it will automatically fetch information, for example, for IP geolocation. If it's related to files, so we'll go and check the hash and enrich the data, try to get as much and many information in order to provide you a clearer picture. He know how to extract observer, so he know how to get the data from the incident in order to provide you more information about it. You know, to anticipate attack and look for patterns in events and alert data to identify them. We have another capability with the CMO that you can interact with. So you have an interactive chat, you can write things there, and he will provide you information back as you go over and work in the incident. Next, please. So what we understood in CyberProof is that it's no longer enough just to provide out-of-the-box use cases. This is where we have a use case factory team that what he's doing is sitting together with you and understanding the business risks. So we are no longer looking on detection or quantity of the use cases. We are looking about the business risk and understanding what are the risks that are related to your industry, to your company, to the things that you are doing. And together with you, the use case factory team building the right playbooks, the right detection rules, and the right integration and automation in order to make sure that we are fitting the detection rule to you. It's like, if we take it to the medical things, so a lot of the things we understand right now that the medical industry, it's not enough to provide a generic one. I understand that they need to see each person what he needs and how it's affecting, and they provide him a treatment based on that. So we do the same with use case factory. It's no longer taking those use cases, it's sitting together and creating it for you, for your risks. Next, please. So we also have a use case catalog, which is ever improving and introducing more and more use cases that are mapped to the MITRE ATT&CK we will see in a second, and that where customers that working with us can easily go inside to the catalog, choose the detection rules that they think that related to them, and a click on the button, they are able to enable it, and they can see it based on the MITRE framework. They can do it based on the risk. They can do it based on incident response and capabilities of this in order to seamlessly one-click deployment have new use cases inside the platform. Next, please. Also, we are really invested in the MITRE framework. I think like everyone, this is where we provide, together with our use case catalog, a MITRE ATT&CK mapping snapshot, where we will show you what are the coverage that you have based on the use cases that you have and the MITRE framework, and how we can further improve your security posture. Next, please. So let's talk about why we are really here, and we understood that SIEMs, the traditional SIEMs, are no longer valid. So this is where we want to go with, based on Forrester, the security analysis platform. This is where Sentinel come into the play. Based on Forrester, so cloud delivery security analysis platform that provide custom detection will dictate which provider will lead the pack. Vendor that can provide customization, MITRE ATT&CK mapping, and SaaS delivery position themselves to successfully deliver improved detection, faster investigation, and flexibility to their customer. Next, please. This is where Sentinel come into the place. Microsoft Sentinel, together with Microsoft, shifting the platform to be from traditional SIEM to be a security analytics platform in the Microsoft XDR stack. And Microsoft Sentinel provide us SIEM capability, SOAR capability, threat intelligence, threat hunting solution, and user entity behavior analysis. And of course, Azure Arc integration, which let us monitor our environment, not only in the Azure cloud, but also in any cloud provider, on-prem, and so on. And this is the SIEM that we will use today in order to present and show the things related to the scenarios around. So thank you.
Cool. Thanks very much, Sagi. So let's get back on to doing a demo of API security. So what I need to do is I just need to explain this, the demo environment architecture. So what we have here is we have, just put that cursor, the pointer on. So we have an API backend that's just running a little application we use called Pixie. We have the firewall sat in front of that. That's acting as a reverse proxy exposing to the public network. We also have the ability to generate the logs from the firewall and push them to Log Analytics and Sentinel. And then what we do over here, we've got, I've had some of these exposed to the public network for the last couple of weeks, gathering, acting as a honeypot. And I'm also going to show this working with Postman. So let's go over and do a little demo. Let's just show what the so let's get Postman here. So what I'm going to do is I'm just going to very quickly show you what Pixie is doing. I'm currently going to hit an endpoint on port 1890. So this is not protected, right? So what we'll do, we'll just log in and check we've got a session. I'll get some user information, nothing terribly exciting to see here. This API has got a couple of issues. The problem is here, we can see there's excessive data information exposure. We're returning a password. It's allowing us to do, we can do a mass assignment, right? And we've updated the user to be an admin. So we've got a couple of typical things that are wrong with this API. And this API is currently being protected by 42Crunch. So let's just flip over, and I use that same host, but I'll just access port 80, save that. I should still have the session. We go back here, we go and get that user information. That's fine. We try and list all users now, and we can see what's happening here. We've been blocked, right? We got a request validation failing. We try the mass assignment again. We can see we've been blocked again, 403. What we'll do is we'll do the mass assignment now without the is password, right? And we'll do that assignment, and we can see that passed, right? So what we've got there, give a very quick explanation there. We've got the, the firewall is intercepting that. It's got the OS definition. It's knowing what's allowed and what isn't allowed. So we have incidents. So let's go and look at those. I just generated a couple of logs there. So let's go and have a look at those logs. So this is the first look at Sentinel. We go through this in a little bit of detail in a moment. And what we have here is we querying. You can see that. Hopefully that screen is legible. We're looking at records in the last 5 minutes. We're sorting by time, and we can see we're generating a lot of issues here. So this is the firewall intercepting those calls. And let's see if we can find one of those. We try to get the user info. I know what I've got there. I've got a script running. Let's just get that script stopped. So let's just disable that. What I'm just going to do now is go back to Postman, and I'm going to do the get user information. Let's just regenerate that. Let's get all users. That won't work. And mass assignment. That won't work. That will. Okay, and we just go and set that to the last minute. Right, so we can access the log. So we're seeing there's the call that I've just done now. Right, and that's that issue. I try to edit the user info. So the firewall acting in place, and just from the architecture point of view, pumping those logs onto log analytics. And then, the real value proposition here is once you get that data onto log analytics, kind of the sky's the limit as to what you can do next. That's the architecture. What I do need to do, because I lost my screen when Sagi was presenting his slides, what I need to do is I just need to go and generate a couple of test cases. So I'm going to access that platform, and I'm going to come from an unknown IP address. So I'm going to make up an IP address. So remember this IP, let's call, well, it's the fourth, right? So let's do, this is the first time that IP address is going to be seen by the platform. So just remember that. We just run that now. We're just writing that access to the API. You can see all those logs being dumped and transferred up to the platform. And we will do, let's do another couple of these. So we've done that first time access. Let's do some rate limiting demo. We show the demos in a second. You can see what's happening there. There's an absolute load of information being transferred up. And we'll do a password reset. Just give it a second while that runs through. And then we're going to go back to this in a second, and the last one. Okay, so we'll let that run through. And as I said, we had that firewall kind of sat on the public internet I left it there for about 6 weeks. And this is really just capturing all the access that we saw. You can see there's a snapshot of the most commonly accessed endpoints. You can see what people are trying to do with this. They're trying to access .env files. They're trying to pull git config. They're trying to pull down secrets. They're trying to access PHP, PHP MyAdmin, WordPress. They're trying to exfiltrate AWS secrets. There's a number of things that they're doing. And then most interestingly, we saw evidence of active scans for three recent vulnerabilities. I can't remember the first platform that was on, It was something Apache Solar, I think. That's the that exploit on the right. And then also there's a Laravel vulnerability, just recently published vulnerabilities, and we can see active scanning for those. Right, so people definitely, you know, will find your APIs and they will get up to mischief with this. So we got a lot of these scenarios. We're talking about API security. We talked about the type of attacks that people are launching. So let's start with the two more benign ones. Just excuse that rather random numbering. There are 11 of these, and they go in order of severity. So scenario 9. So one of the things that you might want to do if you're defending an API is you might want to just investigate accesses from new IP addresses. So this is possibly an indicator of something, you know, you might just want to look into those APIs and kind of work out, establish where they're coming from. So the detection strategy is here. Every time there's an access made to the platform, just check that you've seen that IP address previously, say in the last 7-day window. And then another scenario is on the 42Crunch platform, we've got the ability, one of the basic protections we allow you to do is we only allow access to APIs if they're accessed via a fully qualified domain name. Right, so if you're enumerating an IP address range, so you're scanning Sentinel, scanning Azure, or you're scanning an ISP, if you try and access the IP address directly, the firewall will actually block that access because you need to access it via the host name. Right, and that's a very basic, fairly crude defense mechanism that makes sure that only clients that know what they're trying to connect to via a host name will be allowed. So those are two of those, and that's how I got a lot of that honeypot information. Right, so those are two of the ways that we can, you know, detect issues. So what I'll do now is I'm going to let Sagi take us over to Sentinel. Hopefully we've got a little bit of that event data coming through. I'm going to go and generate a couple more in the background and let him start showing us some of the basics of finding these things on Sentinel. So Sagi, if you want to grab the screen.
Great. So yeah, as what we see now is Microsoft Sentinel, for those who are not familiar with the platform. As Colin said, that sometimes we want to really investigate and hunt for new things, and we don't want to overload the system with incident. So as I said, first time IP address hitting the platform, sometimes it can be legit and it doesn't need to be an incident. And also for the full qualified domain name. This is where we have in Sentinel the hunting capabilities. Together with the hunting capabilities, we can now build our query inside the platform and then on demand run it. So if I take, for example, the first time access, I can click on it. I can see here the query in order to try and find the first time the IP address is hitted the firewall, and I can run the query. Now, what will happen is that the query will run in the background. I don't need to wait and see. And if I go and do refresh, then I can see that we have results. So when clicking on it, I can do the view result. And then I can start and see all the alerts that are related to this query. So we have here the IP address that Colin just typed in, for those who remember. And then I can see all the information regarding this query. So this is where our threat hunting team can go over and look on those logs and decide if this is something that's worth investigating, or if this is something that this is okay and it's not something that is malicious or has any risk. So to get going forward to the second scenario where we talk about the invalid host name, host access, sorry. So we can run the query right now. Actually, we will see results around this. And let's see if we have results. No, we don't have.
Yeah, so yeah, I can see some of the incidents are rippling through now. So, and that's actually highlights. It's worth just talking about this topic while we wait. Yeah. this is one of the the challenges with this log analytics Sentinel. It's not an absolute real time. These aren't instantaneous real time alerts. There's a lot of things in that. And do you want to talk more to that point?
Yeah. So Microsoft is in near real time platform. So it means that there is a time between data getting ingested, it getting processed by Sentinel, and only then it's been showed. So sometimes it can take a little bit, a few minutes until we see the events. This is why it's happened to us right now and we don't see the events. Yeah, overall it will be quite fast, but sometimes it happens. Now, moving on from hunting and choosing a specific scenario to hunt, and of course that we can run all of them together and we don't need to wait. One of the cool things that we have in Sentinel is what we call workbooks. So those workbooks are interactive reports. So what I want to show you right now is that in any time you can go and we build some kind of a report that you can see on top of all our incidents. So we can see requests by IP addresses. So we can immediately spot up IP addresses that are doing a lot of requests regarding others, compared to others. You can see the status code that return. So you can see overall what the status codes we return by the instances. And we can also see the distribution of alert based on firewall instances. So we can see here that firewall dev 3 is working much more than firewall dev 4. We can also have a request over time and see how many requests we have overall in the platform and distributed based on the various firewall. And we can try to see trends and try to see how it's behaving over time. One of coolest things that we had is query by location. So we can see the areas that are interacting with our APIs. So we can see here that we have a lot in California, we have in Michigan, and of course we have China. And this is how we can identify the areas and maybe in terms of security, try and hunt down, because we know that there are locations or IP addresses that are well known as malicious. And from the other side, we can really understand this in terms of IP and see where are our users. And maybe we can even work on latency and things like that regarding the geolocation. Now, the nice part inside the workbook is that this is interactive. So I have here the firewall instances, and I can click on one of them. And what happens is then it will automatically create me another report that is focused specifically on this instance. So you can see request over time for this. We can see request by IP addresses, and we can see request summary by URI. So we can see which URI are being used, how many requests we have, how many of them are failed requests, and how many of them are successful requests. And from the other side, we can also see my source IP addresses. So we can see the number of requests, the number of failed requests, and the number of successful requests. So by clicking on them, on the IP addresses or the URI, we can also see more information. So we can see here a summary of a request by an IP address, see exactly what status code he got, what the URI path that he used, and what error message he got. Yeah, and from the other side, I can choose any URI path and see exactly all the requests from which IP address it came, how many times, and what is the status that it get, and what is the error message that he got. So those two things, the hunting capability and the workbooks, allow us to do proactive activity and try and understand how our platform works and who interact with it, and so on. Now, inside Microsoft Sentinel, like any other SIEM, we also have the incident pane. So the incident is where the platform, based on the logic that we configure, know how to group number of alerts, and create some kind of actionable incident that we can then investigate and see and work on it. So Colin, I will send it over to you so we can talk about the attack scenario, and then we'll see how we can monitor them inside the platform.
Yes, thanks very much, Zaggy. So Zaggy's already shown the IP address account thing that came through. We've also got 3 incidents. So I did 3 things here. So let's just look at the scenarios. I'll get that order right soon. Scenario 1 is account takeover. So what are we looking at here? We'd spoken about account takeover being one of the techniques. Typically what will happen is if an attacker can find that you've got things like reset endpoints, they'll try and brute force these. They'll try and guess reset codes and whatever. The easy detection, if you see an excessive number of 403 errors on these endpoints in a burst, detect and latch on those. Scenario 2 is password cracking. Again, this is just a credential stuffing attack. Easy to detect against as well, and then you can back off and kick that out. And then the other one that I looked at was the I think it was rate limiting. So one of the advantages with the 42Crunch firewall is the fact that you can do rate limiting in the firewall rather than having to implement rate limiting in your code base. The advantage is obviously if your code and your application is battling to respond, then you've already been subject to overload. So you do the rate limiting in the firewall. And the way we do this is if we see an excessive number of requests within a time window, we start returning 429 errors on that. So how do we detect that on Sentinel? Let's go have a look at that in a moment, because what I'd seen is, remember I'd shown previously that we didn't have any incidents. We've got 3 brand new incidents coming through, and lo and behold, they are scenario 1, 2, and 8. And just to show that we're able to automate that and hit that through to Slack, so we can get those alerts coming through on Slack. We've also got an informational one here, that invalid host access, which actually means, what that means is, while we've been doing this webinar, somebody has accessed that, try to access that endpoint. We'll go have a look at that in a moment if we have a moment. But that's just showing the power of the integration with Sentinel. Once you get the information into Sentinel, kind of the sky, within reason, the sky's the limit as to what you can do with that information. So we looked at that account takeover. I think what I'm going to do, the rate limiting is the last one to explain and have a look at. So rate limiting, we can have a look at the details of that rate limit. We can do, we can see the account name, the host name, the IP address where that came from. Sagi's already shown us looking at the events. We should now have an event here, right? We've got the event. We can see where that came from. I am spoofing these IP addresses just for purposes of demonstration. And we can see that login that we hit, and we can see that we got a 429, right? So pretty simple to be able to do that level of detection. Which other one is a good one? So password takeover, same kind of scenario here. We can see we're getting, Sentinel is enriching this event data for us. You can map, Sagi showed those IP addresses appearing on a graph. So what I think I'm going to do now is I'm going to take, because we want to talk about API security now. So let's go and have a look at some of the other types of things that we can defend against. And I have prevention and detection of this. KiteRunner is an interesting one. So KiteRunner, if people aren't familiar with KiteRunner, it's a tool that lets you enumerate an API. So if you're wanting to hack and attack an API that you don't know about, all you do is you point KiteRunner at the base URL, and you go and run a detection, and it just does a brute force a dictionary attack. So what I'll do now is I'm going to run KiteRunner now. So if I just do that, right, and you'll see off it goes, and KiteRunner is going and enumerating that API. I'm just using the small dictionary for this demonstration. Right, so there what we found, we found an API register endpoint, we found an API login, we've got 403s because it wasn't able to access that. Right, so KiteRunner has produced a report and said, look, here's the API endpoints I think you've got. So Sagi, if you want to grab the screen.
So if we go back to the incidents, we can see those things. One of the things that is nice is that inside the Sentinel, we have the entity behavior, so we can see the IP addresses that Quali just used and the host that he's using, and see how it's working and how it's related to a lot of the events that we are seeing in the platform. So it allows us, and you can see here the alert and activity timeline. So we can see that this IP address try to access an invalid host, and we can see here exactly when you did it and when, and also, as he said, so Sentinel is enriching the data, so we can see exactly to which organization this IP address are related and to which countries came from, and so on. Now let's see if we have the incidents already. So let's see. Yeah, so we have the rate limiting. So one of the things that this scenario doing is that when the kite run is going and doing a lot of queries, so we want to limit it. So we want to see we have some kind of thresholds that we work with, and we want to make sure that a specific IP address is not doing a lot of requests in a very short amount of time. So we can see here the investigation pane, and we can see exactly what are the IP addresses. And we can see here, you can see more information about it and see if it is related to any other alerts. We can see here the things that are related to the instance itself. So we can see here that we have more incidents related to our firewall. So we can see here other things, and we can go on and continue our investigation and drill down to make sure that we see the big picture. Now, regarding the logs, so one of the things that we can do, we can, where is it? Go to the IP address. And sorry, not here. Let's go to the Microsoft Sentinel. And we can see the logs. And this is where we have so this is where we can see a lot of the requests. So we can see that they are coming, and we can see here that there is a lot of requests that come in for the same host. So those are the things that we want to make sure that we locate in order to mitigate the kite running.
Okay, so that was Kite Runner. So being able to detect multiple attacks, brute force enumeration. There's other things that we've been able to do: anomaly detection, being able to, this is so-called business logic errors. I've got a sudo bolo working where if you can see that you're attacking a sequence of accounts the wrong way, suspicious login, if you're accessing from multiple IP addresses, so impossible movement. API scraping, if you polling and paginating APIs frequently. Rate limiting we looked at. JOT validation, I can also do that. The firewall, the 42Crunch firewall will ping us if we don't validate a JOT token. So you can do this outside of your API. You just let the firewall do that for you, and then you can log that through to Sentinel. Some quite interesting use cases here for what we were able to do once we were actually able to get that data. So just in conclusion, just in the last couple of minutes, so just, I know there's a question, we'll answer that in a second. So some of the use cases and benefits, I mean, we didn't really look at, there's lots of things that you can do once you have that data on Sentinel. So you can, for instance, one of the things you could do is you could actually fire up the Azure network security groups and firewalls and block rogue IP addresses at the network level. You can go and do things like Azure Active Directory and go and block accounts. The takeaways for me are cost reduction. I think that's the big one. Why duplicate your security spend on buying a dedicated API security monitoring tool when you can actually just, you've already got a SIEM or SOC solution like Sentinel, just integrate into that. Right? No need for a duplicated purchase. Accuracy, we're working at the API level. We're actually intercepting that API traffic at layer 7, right? We're not inspecting traffic at layer 4 and trying to infer what is an API and what isn't. We know what is. We've got that coming through that API firewall. It's a simple solution. Your SOC analysts are by far your biggest expense in an organization. I'm sure Sagi knows how much money big organizations spend on SOC centers and analysts. Don't make them go and learn another tool. Just let them use the tool that they know how to use. Integration, we spoke about. If you're on Azure and you've got this logging information in Sentinel, integrate that with your firewall, your AD. You've got that tight coupling and that tight integration. And then also, because the firewall is offering you protection, what you're able to do there is you're able to do hot fixes almost at real time. So as you detect a new threat, you can actually just update the OAS and redeploy it. Right, so a lot of benefits and advantages to this. So quickly, I'll start answering the questions. If you could pop that up for me, please, Hugh. So how are you currently protecting your APIs? And I'll answer the question from Frank. He spoke about design first techniques, didn't give any detail on that. The typical approach that people would have is they'd use an API design tool. Stoplight is the one that I normally use. Write the specification in that, then audit that for security and integrity and fully valid specifications. 42Crunch have extensions for most of the popular IDEs and editors. Go and grab one of those and make sure that you're auditing your API specifications and you're making sure that they're as well specified as possible. Okay, so that's the design first approach. And then to generate code from that, there's a number of code generation tools. Something like Swagger CodeGen can generate clients and servers for most common languages. Hugh, if you could pop the answer to that up, please. So application logs, that doesn't particularly surprise me. I think that's the way most people are doing it at the moment. So that's great. Learning more, if you want to just screenshot those. API Security IO newsletter, where I talk about all things API security every week. And then the question was asked, I answered in the live session there. I said we put the repo available publicly. There's the link to that. If you go onto 42Crunch on github.com, you can go and grab that code, and if you can get playing with that. Hugh, if you'd like to just conclude for us, please.
Sure. Thanks, Colin. Thanks, Sagi. Yeah, just some brief, folks. We're at a number of events this month. First one up is Glue. And if you're not familiar with it, it's very much targeted at enterprise architects, development folks, security folks in Colorado, where our colleague Andy Wright will be presenting on automating API security as code, API security with security as code approach. So that's in Colorado, May 18, 19. If you do want some discounted passes, please send us an email. We still have a few left. And then in June, we will be at the Gartner Security and Risk Management Summit in Maryland. We've been invited to present by Bill Dupree and Dionisio Zamurle from Gartner at their API Security Showcase. We'll also be exhibiting there. So if you are at the event, please do swing by and say hello to the team. And finally, there's the URLs behind those QR codes that Colin shared a moment ago. So Colin, do you want to wrap up to say anything at the end?
No, I don't think so. I think we're good. I hope we've answered questions. Come and talk to us on apisecurity.io. Happy to talk more about this. We'll probably be doing a follow-up blog post on this as well, because I think we went through some of those scenarios in a lot of detail. There's a lot more that can be said about them.
Great. So once again, thank you, Colin, and especially Sagi. Thanks for joining the team today. Great to have you on board. And hopefully, folks, you saw a lot. It's posed a lot of questions, and we've hopefully addressed them all. If not, we'll follow up with you in person afterwards. Thanks again.
Thank you very much for having me.
Our pleasure.